Hello students, today we are going to learn something important reaction, that is reaction with alcoholic KOH and aqueous KOH. It reacts with haloalkane. What are the products? Okay, now last video we have gone through elimination reaction that comes under Steiser rule. We have gone through very clearly. Okay, now in this point KOH, alcoholic KOH and aqueous KOH. Generally KOH, it is a very strong base, you know very well. Okay, now in one point, it acts as a nucleophile. What it acts? It acts as a nucleophile. The other point, it acts as a base. Now, nucleophile means it attacks that positive center, whereas base means it obstructs the proton. Now, where it attacks the nucleophile, where it obstructs the proton, now we are going to see in these two kind of reaction. One, it is elimination reaction. The other one, it is substitution product. Okay, now nucleophile means at once you should remember that it gives only the substitution product. Substitution product. The other one you know very well. This one gives substitution product, means base gives what it is. You know what is the reaction name? It is called elimination reaction. Elimination reaction. Okay, in elimination reaction, it obstructs the proton. That means it takes the adjacent carbon atom, attaches to that hydrogen. That is going to remove that OH minus ion, which is going to remove that. Where there is a beta carbon, adjacent carbon attaches to the lesser number of hydrogen, that point which is going to remove. But whereas here substitution product, that is OH minus ion, which is going to attack the positive center of the carbon. That means carbocation it is going to attack. Hope you're clear with it. Okay, let us go for the reaction. Now let us go for these two reaction in one, two in one process like. Okay, now KOH, first one we are going to take aqueous KOH in that substitution reaction. How do we say it is a substitution reaction? Yes, let us go for this reaction. Carbon connected with, it is a haloalkane, right? So hydrogen here, halogen. Yes, of course, here R will be there. I didn't put it that R. Why? Because OH minus is going to attack. I just put it. Okay. Now, what is the product? That aqueous KOH completely dissociate and it forms nucleophile. Nucleophile, it is a negative, and when you are removing that halide, you will get a positive charge, carbocation. So when this positive charge is there, nucleophile which is going to attack the positive center only. Now what is the product you are receiving? Of course you are receiving what it is, OH. So then you will get halide removal. So in this point you are getting alcohol as a product. Alcohol is the product. When you are getting that alcohol, when that alkyl halide reacts with aqueous KOH, it completely dissociates and it forms as a nucleophile. It acts as a nucleophile. Nucleophile will attack that. Nucleophile will attack the positive center, then it forms as an alcohol. Yes, you know very well. Okay, now whenever they are asking question, aqueous KOH, when it reacts with haloalkane, what is the product? 100% it is alcohol and it comes under substitution reaction. I hope you know this mechanism, substitution reaction mechanism. Yes, now come to that point, elimination reaction. Elimination reactions means removal of hydrogen as well as halogen, that is dehydrohalogenation. That is what yesterday class we have gone through. Yes, let us go for that. In that elimination reaction, hydrogen obstructs. From where that hydrogen it obstructs, that is proton obstruct. So where it is getting from that, it is from the adjacent carbon. Where that adjacent carbon, wherever the substituent component it is attached to that carbon, the next carbon which is adjacent carbon. Now we are going to see another one more reaction, that is elimination reaction, that comes under alcoholic KOH. Alcoholic KOH reacts with the haloalkane. What is the product? Come on, let us go for this. Now alcoholic KOH combined with the haloalkane, you are getting the product. So that comes under what it is, elimination reaction. So what is the mechanism for elimination reaction? Removal of hydrogen and halogen, that is dehydrohalogenation. Already I mentioned what it is, elimination reaction. Come on, let us go for that. Now R carbon connected with here two hydrogen, and here hydrogen, here halogen. Now OH minus ion. Yes, of course, alcoholic KOH, OH minus ion. Here that OH minus ion acts as a base. Okay, now you please note down here alcoholic KOH, this OH minus ion acts as a base. But whereas here this OH, aqueous KOH, it acts as a nucleophile. Nucleophile. Please note down so that it will be easy for you to understand. When it comes under nucleophile, this is substitution reaction. When it comes as a base, that means it acts as a base, means it comes under elimination reaction. Elimination reaction means it obstructs the proton. Yes, which proton it's going to obstruct? Of course, this halogen we are removing them. Now this, which is the lesser hydrogen, of course this R, it is CH3 or C6H5 it may be. Okay, but here which hydrogen we can go for it, which is lesser. Now this is a alpha carbon, this is a beta carbon. So the beta carbon which is having that lesser hydrogen adjacent carbon, there only this OH minus which is going to obstruct. So what is the product you are getting? Of course here what it is, R CH double bond CH2. Alkene you are getting. Of course, when it acts as a base, KOH acts as a base, then you are getting what it is, alkene. So you are getting alkene is one product, alcohol is another product. When nucleophile acts as a KOH acts as a nucleophile, you are getting alcohol. When KOH acts as a base, you are getting alkene. And choose the correct answer, or give reason question. Suppose if they are asking, hope you will do in a better way. Hope you understood. Okay, now next one what we are going to go through, upcoming point. Okay, hope you're clear with that. Let me go, explain once again. In that substitution reaction, KOH acts as a nucleophile. In that OH minus ion, it attacks the positive charge. Yes. Now, when it attacks a positive charge, you are getting alcohol. Yes. Now, that is a replacing. Substitution means it replaces. Now, that another point, elimination reaction means completely eliminate, removal. So, what are the points to be removal here? Hydrogen and halogen. Which hydrogen? Halogen, of course, the last point. Which halogen? Where there is a lesser number of hydrogen which connected with the alpha carbon. What is alpha carbon? The component, substituent component which is attaches, that is alpha carbon. The next carbon, it is an adjacent carbon. This is beta carbon. So this is beta elimination. So OH, here this OH, KOH, OH acts as a base. So this one, it is going to obstruct that proton and you are getting alkene. Hope you're clear with that. Okay, now let us go for another one more reaction. Now, another one more two-in-one process, that is elimination and substitution. Here, salt of butyl, tertiary butyl alcohol and sodium ethoxide. Both are like similarities. But what are the products? Haloalkane only it is going to react it. Okay, let us go for the tertiary butyl. Carbon connected with 3CH3, right? CH3 and CH3, of course. Here O. I just put it O only because anyway salt of T-butyl alcohol combined with haloalkane. No, I just put it ethyl chloride. CH3. I just put it here like this way. Hydrogen, CH3, CH2, and here Cl. Okay, now here if it reacts, what happened? This is actually what it is, minus Na plus what it is, alcoholic, that is this one, it is a minus. Now but this minus which is going to attack where there is a positive center, so automatically this one we are going to receive here, it is T-butyl alcohol. Yes, this hydrogen connected with this here. naturally we are getting what is it? Tertiary alcohol. Now the bond broken, so automatically this bond goes over here. Now what is we are going to receive? Of course it is, anyway, this halide will be removed. Okay, now in this point which is remaining here in this CH2 double bond CH2. Now we want that main product only. What is the main product here? We are getting alkene. What we are getting? Alkene. Alkene. What is the name of it? Ethene. Very good. Okay. Now, in this, I wanted to mention salt of butyl alcohol acts as a base. Why it is acting as a base? Here, because this is a bulkier group. So bulkier group comes means it acts as a base, it comes under elimination. So 2 points you have to be noted down. So where it acts as a base? When that bulkier group comes, it acts as a base. Now another one more point, elimination comes. Elimination comes naturally, that point it abstract that hydrogen, that means it abstract that lesser number of hydrogen. Yeah, also you can mention that, and it you will get the product, it is alkene. In here, I wanted to mention one point. The negative charge which is take over the hydrogen and form as a T-butyl alcohol. So the bond broken, then you are getting a double bond. In this point, mainly I wanted to mention elimination reaction. This, because of this bulkier group, it acts as a base. That is the main reason. Why it is coming under elimination reaction? Because this T-butyl, salt of T-butyl alcohol acts as a base. Why? Because it is a bulkier group. That is the reason. And bulkier group, base means it comes under elimination reaction. What is the product? You are getting alkene is the product. Okay, now let us go for the substitution reaction. That is what it is, sodium ethoxide. We can take that example as a sodium ethoxide, C2H5O combined with isopropyl bromide. Okay, I just put it isopropyl bromide, CH3 CH, here CH3, here Br. Okay, now of course Br will be removed. And now here this O, this is a negative charge, right? The same way here. Here also negative charge. Now where it will go and attach? Why? Because it is substitution reaction. Substitution reaction means it is acting as what it is. So that means here negative charge which will go and attack with that carbocation. So naturally this is removed means automatically this will become a carbocation. So this is which is going to attack the carbocation. So you are receiving what is the product. Okay, let us go for that product. Here what it is, CH3, here CH, here what it is, CH3, here OC2H5. Okay, what is the name of it? Can you guess? Here CH3, CH, CH3O, C2H5. Come on. Here the name it is 2-ethoxy propane. Right? 2-ethoxy propane. Okay. Now come to this point. Here this acts as a nucleophile. This point, why it acts as a nucleophile? Because it searches the carbocation. So in this substitution reaction means it acts as a nucleophile. So here in this point it acts as a nucleophile. Okay, fine. But here salt of T-butyl alcohol, here it acts as a base. Why? Because it is a bulkier group. The same way salt of ethoxide acts as a nucleophile. Why? Because it searches the carbocation. Here elimination reaction, here substitution reaction. Same comes under in one. Hope you're clear. This is also salt and that is also salt, but the product will be different and the reactions are vary. 2-in-1 process. Okay. Hope you're clear. Why we are getting alkene? Because of bulkier group. Why we are getting oxy? 2-ethoxy propane, oxypropane, ether. Oh, so how do we get it? Because it is acting as a nucleophile. It searches that carbocation. Hope you're clear this mechanism. Two reaction in one process. That means these are the two reaction comes under one component. Hope you're clear with that. Okay, next reaction, Wood's reaction.